So this drawback of scatter plot, failing to give us the degree of linear relationship between x and y, could be overcome by applying a mathematical method, which is Karl Pearson's coefficient of correlation. Karl Pearson's coefficient of correlation is a mathematical quantity which helps us measure the degree of relationship between x and y. The notation that is typically used for indicating coefficient of correlation is rho in the population, and for the sample we use small r as the notation for coefficient of correlation. So here are the formulae to compute the Karl Pearson's coefficient of correlation, and the range within which we expect this coefficient of correlation to lie is -1 to +1. Based on the different values of r, we shall be able to interpret the relationship between the two variables x and y, like how we did it using scatter plot. So if the Karl Pearson's coefficient of correlation is equal to +1, then it indicates that there is a perfect positive correlation between the variables x and y. Similarly, r equal to -1 indicates a perfect negative correlation. If r is closer to +1, it indicates the strong positive correlation between the variables x and y. If r is closer to -1, it indicates a strong negative correlation between variables x and y. And finally, if r is equal to 0, then it means there is no correlation between the two variables x and y, which actually indicates that there is no point in studying the two variables together. It's important to understand that r measures the degree of linear relationship between the two variables x and y. Hence, whenever we get a high value or a large value for r, which could be either closer to +1 or -1 in the sample, it is also important to test the significance of this coefficient of correlation in the population. To do so, we perform a test of hypothesis for the significance of the coefficient of correlation in the population. To do so, we set up a hypothesis H0, which says that the coefficient of correlation is insignificant in the population, whereas the claimed hypothesis, that is H1 or the alternative hypothesis, is such that rho is not equal to 0, indicating that there is a significant relationship between x and y in the population. Whenever we are performing any test of hypothesis procedure, there is a test statistic which enables us to decide whether to reject the hypothesis H0 or to retain it. Here is the test statistic given by T, and it follows T distribution. Using this T distribution, we will be able to compute a value which is called as a p-value. This p-value, when compared with the level of significance, will allow us to decide whether to reject the null hypothesis or to retain it. All the statistical softwares using which you are performing a test of hypothesis give us a p-value. This p-value, if it is very large or it is greater than 0.05, which is the level of significance, then you decide not to reject the null hypothesis H0. Basically, we compare p-value with the level of significance in order to decide whether the population correlation coefficient is significant or not.